Welcome to CS420, Lecture 12, and today we're going to be talking about environments. Environments are a data structure that we use to store all the values of the variables that are in scope. So we need some place to store their values, so whenever you see a variable in your code, you can look it up and find its value. And environments do need some sort of nested structure so that we can, as we enter in a new scope, we can have all the variables declared in that scope in one data structure. That way when we leave that scope, we can have those variables go away. And we do that so that we can have static scoping, which, if you remember from a previous lecture, static scoping really makes a lot more sense and reduces the error than having dynamic scoping, where all the variables you've declared can conflict with all the other variables if they happen to have the same name. Now we're going to create an API for our environments. Now if you don't know what an API is, it stands for Application Programming Interface, and it basically just defines the functions that we can call to be able to implement our environment. Now we really don't need to know how it's implemented. Notice the dots here. All we need to know is the name of the function and the parameters that we use to call that function. And we abstract away all of the details. So there's three methods. The first method is to create an empty environment, something to start off with. And then, as we declare new variables, we'll extend that environment with the new variable names combined with their values. So the extend env takes in an initial environment, and it extends it with new variables and new values. The third method is called apply env, and this is to look up a value in our environment. So we pass it an environment and then the name of the variable we're trying to look up, and it will return us our value. So if we're trying to do this example up here, a plus 2, then what will happen is we'll pass in our environment and a, and it will return us the value of a. And that way we can add 2 to it. Now it doesn't really matter how these are implemented. It just the most important thing is how you would use these. And you can see in our lecture notes we have an example where we start off with an empty environment, and then we enter in a new scope block where we declare a and b, a being equal to 1, b being equal to 2. And then a third environment where we declare c, d, and b, where c is equal to 3, d is equal to 4, and b is equal to 5. And that extends our environment. And now we can use these functions to look up the different values in those environments. Now, usually it's really useful to be able to visualize how our environment looks. So that environment that I just created, at first we had the empty environment that doesn't have any variables in it. If we try to look up a variable in our empty environment, this is where we will error saying, hey, that variable name has not been defined. The first environment we created right here, a and b, so we extend our empty environment and we set a equal to 1 and b equal to 2. Then in the next environment that we extend, where we declare c, d, and b, c being equal to 3, d being equal to 4, and b being equal to 5. In this case, when we're looking up a variable in our empty environment, the first environment, then we're going to get an error. If we look it up in this extended environment, we'll see that a is equal to 1. Now if we look a up in the third environment, we'll still find this a and that is equal to 1. Because if we don't find a in this environment, then we go up and check the environment it extended. And in the third environment, and then in the second environment, if we look up b, we start in the second environment and we find that b is equal to 2. But in the third environment, we're looking up b and we find this b first, and we don't even bother to check with the rest of them because we already found a b, and we see that b is equal to 5. So in this case, once we find a name in the topmost environment, we'll just return its value, and we won't continue checking other environments for that variable name. And that's because we were implementing static scoping. So if we enter in a new scope block and define a variable whose name is equal to a name in the previous scope block, then we want to use the variable that we just declared instead of a variable that might be in a scope block up above. By the way, when we enter in a new scope block in Java or C++, that's whenever you enter or call a new function. In Racket, you create new scope blocks in two ways. One is with a let expression, where you declare new variables, and two is with a lambda function. Whenever you call a lambda function, you create a new scope block with new variable names being the parameter names to that function. Now the lecture notes talk about two different ways that we can implement these environments. And again, implementing the environments is just filling out these ... dots. So it's not really important to know how these work internally. It's just important to know what they do. So you can read through this. I think this procedural implementation is very interesting. And it takes into account first-class functions, and we create new functions that actually store our environment inside of the function, which I think is a really new and novel idea. So you can read through the code and see if you can figure out how these work. We're going to stick with this data type implementation. We're going to create a new data type that is either an empty environment or an extended environment. And we also have to have this function here for our type checking so that we can have any scheme value. In this case, any scheme value, whatever we have will be a scheme value. Now these notes were written back when we were using scheme, so you could call this a Racket value if you wanted to update it now that we're using Racket. And we can see the three different functions. This creates an empty environment, this extends an environment, and this is the code to apply the environment. Now that assumes that we've also written this little helper function that helps us find variables, find their position in a list. So these two helper functions do need to be in here even for the data type implementation. Now we can see each one of our three environments. Our first environment is just the empty environment at the bottom. The second environment is the one that has A and B in it, A equal to 1, B equal to 2. And our third environment, it has C, D, and B equal to 3, 4, and 5, respectively. Now if we apply the first environment to A, we get this error and no binding for A. That's another way to say this is A is undefined. So if we're looking up any variable in an empty environment, we're always going to get undefined. Now we can try to apply A to the second environment. And we see that the value of A is equal to 1. A is equal to 1. And now let's try in the third environment. And we see that A is still equal to 1. So what happens is we look in this environment for the variable A and we don't find it. So then we go to the environment that got extended. And that's this environment. And then we find A in here and we see that it's equal to 1. Now let's go ahead and try to look up B in this second environment. And of course B will be equal to 2. And when we try to look it up in the up in the third environment, in this case we're looking it up in this environment and we find B is equal to 5. And lastly, what if we look up a variable that is not declared? So we get this error message. So what happens is we look in the third environment that extends the second, and we don't find the variable t. So then we ask the second environment to try to find the variable, and he doesn't find the variable t. So then it asks the first environment, that's the empty environment, and whenever we try to look up something in the empty environment, we're always going to get this no binding for this variable name.